Hi everyone, in this video we will be discussing about calculating molarity concentration with a given specific gravity or density and mass percent of a substance. So before we start calculating problems, let us discuss what properties are gonna be used in solving the problem. So first is we are solving for the molarity. So molarity, as we know, is M or mole per liter. So this is our target unit. So this is the concentration unit that we will find based on a given specific gravity and mass percent. So first, let's talk about specific gravity. Okay, so specific gravity is often referred as the density. Okay, but uh, these these two are different. Okay, particularly specific gravity or SG is equal to the density of a specific substance over density of water. So why do we usually make density equal to specific gravity? Okay, so this is the case. The density of water at normal condition, okay, let's say normal condition, so meaning this is the usual condition. Usually this is 25 degrees Celsius at 1 atm pressure. Okay, so the density of water at this certain condition is approximately 0.997 g per ml. Okay, so this can be approximated as 1 g per ml. Okay, so if you imagine this density of water is equals to 1 g per ml. Thus, Sg here is equal to density of a substance over 1. Okay, so if you divide some value over 1 is just equal to that value, right? So oftentimes Sg is just equal to density of a substance. And this will be a useful insight that we can use in the problem later. Okay, so specific gravity is equal to the density of a substance. The next thing we'll talk about is the property known as the mass percent. Okay, mass percent. So we have a word here, uh, percent. Okay, let's discuss about that first. Okay, mass percent. Okay, when you hear percent, this is the ratio, right? The ratio of a number to 100. So when I say 50%, that is approximately 50 over 100, right? When I say 61%, that is just 61 to 100, okay? So let's have a real life example. Okay, let's say that, for example, I have a box here and I say that 60% of this box are apples, 20% are orange, and 20% are mangoes. Okay, so this implies ratio of a number to 100. So let's say this box contains um, 10, uh, 10 fruits. Okay, so 60% of 10 is 6. Okay, so 60% of 10 is 6, which is there are 6 apples And 20% of 10 is 2 orange, and 2 mangoes because it's also 20%. Okay. So basically what we did here is 60 over 100. Okay. Ratio of a number to 100. That is 0.6. And when you multiply 0.6 to 10, which is the total number of fruits in the box, that would be 6. So you can say that there are 6 apples because 60% of the box are apples. 20% are orange. So in the case of orange and mangoes, that would be 20 over 100, 0.2 times 10 equals 2. Okay, so that's how percent works. But we have here mass percent. Okay, so this is usually done in chemistry. So this is like a real life example, but let's have like a view of what are the units used in chemistry. Okay, so we have mass percent. It is also indicated as weight per weight percent. Okay, we also have volume percent or V per V percent, and we have volume per weight or weight per volume percent. Okay, so these four are different. Okay, when you say weight percent, this is just gram of a sample of a substance per 100 gram. So for example, uh, the solution is 20% HCl. So we can say that its weight per weight percent would be 20 grams per 100 gram solution. Okay, so this is 20 gram HCl per 100 gram solution. So this is indicated usually with this weight per weight. Okay, when you say volume per volume, that would be XL over 100 ml. Okay, so it's the same thing when you say the solution is 20% HCl and it's indicated in V over V, that would be 20 ml per 100 ml solution. Okay, so weight per volume, okay, X gram per 100 ml, and volume per weight is just X ml per 100 gram. Okay, so they just used weight indicate that it is a mass. V indicate that it is a volume, so you can use ml or grams interchangeably. Okay, these properties we will use to solve problems or calculate molarity concentration. Okay, so remember this principle from specific gravity and mass percent. Okay, let's solve problem number 1. Calculate the molar concentration of nitric acid or HNO₃ with a molar mass 63 grams per mole in a solution that has a specific gravity of 1.42 and is 70.5% HNO₃. So first things first, we can see here we were given the specific gravity, which is 1.42. So we could say the density would be 1.42, and that is in gram per ml unit. And we also have here 70.5% nitric acid weight per weight. So this is mass percent. So this is 70.5 grams HNO₃ per 100 gram solution. Since it is in mass percent, so it would be X gram per 100 gram. Our goal here is to get a unit, which is molar. Okay, specifically mole of HNO₃ over liter of solution. Okay, And we will use the specific gravity and the mass percent to solve this problem. Okay, in solving this problem, let's start with the given mass percent. Okay, so that is 70.5% nitric acid. So 70.5 grams HNO₃ over 100 gram solution. Then we want to convert this into mole units, since we want mole HNO₃ in the top, right? As you can see here. So let's use the molar mass. Okay, 1 mole of HNO₃ is 63.0 gram HNO₃. So with that, we can cancel the gram HNO₃, and we're left with mole HNO₃ per 100 gram solution. So we want this to be converted into a liter. Okay, let's use the density. So the density is 1.42 grams. 1.42 grams per ml. Okay, use this specific gravity. Then we can cancel the grams. And note here, we're not done. Let's convert ml to liters. 1000 ml is 1 liter. And we are left with mole nitric acid over liter. And we can solve this now using our calculator, which is approximately 16.0 molar. Okay, so this is the molar concentration of nitric acid. This is usually how you solve the molar concentration of a concentrated acid based on the labels found on its container. Okay, so you need the information such as the density or the specific gravity and its mass percent. Okay, okay, let's do the next example. Okay, for number 2, hydrochloric acid solution is 36% HCl by mass and a specific gravity of 1.18. Calculate the molar concentration of HCl in the solution. Okay, so let's look at first the given. Okay, so we have the density from the specific gravity, which is 1.18 grams per ml. Okay, and we have the mass percent, okay, which is 36.0%, and let's convert that to 36 gram HCl per 100 gram solution. And let's solve this. So as usual, let's start with this. So 36 gram of HCl over 100 gram solution. Now let's multiply it with its molar mass. So 1 mole of HCl, okay, it's given 36.46. 36.46 gram HCl. Okay, it's given here. And then we can cancel the gram HCl and we're left with mole HCl per 100 gram solution. And now let's use the density or the specific gravity to convert this into a volume unit. So we have 1.18 grams per ml, and we can cancel that. And let's convert ml to liters. 1000 ml is 1 liter. Cancel that. And we can solve this now, giving us with a unit mole HCl per liter. Okay, and this is 11.7 molar HCl. Okay, so that is the molar concentration of the 36% HCl bulk per weight. Okay, so that's easy, right? Once you understand how units or how you can arrange this through dimensional analysis. Okay, so for last question, okay, number 3, a nitric acid solution is labeled 68% nitric acid weight per weight with a specific gravity of 1.421. Determine the molar concentration of nitric acid in the solution with the given molar mass 63.01. Okay, so this is the same as number 1. We have a nitric acid solution that this time it has a different mass percent. So this can be the case. So we have different manufacturing of acids, and so they may have different labels as well. So it's important to understand how to solve its molar concentration. Okay, so let's start for the solution. Okay, we were given first is the density, which is 1.41 gram per ml. So from the specific gravity. And then we have the mass percent, right? So mass percent is 68.0% or just 68 grams of nitric acid per 100 gram solution. Okay, so let's start solving. So let's start with the mass percent. 68 grams HNO₃ over 100 gram solution. Then let's use the molar mass, which is given here, 63.01 grams. 63.01 gram HNO₃ is the mass from 1 mole of HNO₃. Okay, so now we can cancel the gram unit. Then after that, let's use the given density from the specific gravity, which is 1.421 grams per ml. We can cancel the grams of solution. Then let's convert this to liters. Okay, 1000 ml. And let's cancel ml, leaving us with mole nitric acid per liter, which is uh, 15.2 molar HNO₃. Okay, so as you can see, it has a value closer to our nitric acid answer from number 1, right? It was 16 molar, but it's different. Okay, so this can be a case. Different manufacturer have different molar concentration or concentration, even though they have the same acid. So that's all. Thank you for watching the video. I hope you learned